Hey everyone, welcome to DataMillennials. I am Atul and in this video we are going to discuss about the recursive function in Python. So a recursive function is a sort of a function that call itself in order to resolve a particular problem. The function generally includes a base case, which is the condition under which the recursion basically ends, and a recursive case, which is where the function call itself again and again. Okay, so let's take a simple example of recursive function in Python. The first example that we're going to work is the factorial of a number. So let's say if I have to get factorial of number, then what would be the operation? The operation would be 5 into 4 into 3 into 2 into 1. And if I basically run this, you can see that we're getting 120, and this is the operation that we have to do. So we have to go back to this number. Okay, and the first thing that we are doing is that take this number, then put 5 minus 1 and multiply it with the previous number, then with this number minus 1 and multiply it with previous number, and it goes on till the value is 1, right? So this is what we are going to do in this recursive function. So we are going to define a function named as factorial. In this we are going to take an argument n. Okay, so let me comment it out first over here. For this n we would be finding out the factorial. Okay, the first condition that I want to check in this factorial is that whether this n is equal to 0 or not. If it is 0, or let's say n is equal to 1, then we always have to return the value 1. Even the factorial of 0 is 1, right? Then if that is not the case, then we have to give the else argument saying that basically return the value n multiplied by factorial function, or call this factorial function with n minus 1. Let me get the output into a result variable, result equal to factorial of 5. Okay, and then we are going to print this result. So if I run this, you can see that we are getting 120 as expected, right? So what's happening in this code? So we have defined a function named as factorial that takes one argument, which is n. Okay, then we are checking if n is equal to 0 or n is equal to 1, and if it is, then return 1, and this is our base case. Against this base case the condition is checked. Now if that is not the case, when I'm saying if that is not the case, this means that if n is not equal to 0 or n is not equal to 1, then we'll go to the else part. So in else part we are sure that n is not 0 or n is not 1. Then we are proceeding to the next line, which says return n into factorial n minus 1. So we are returning the value n multiplied by the result of n minus 1. So we are calling this factorial function from here again, and this will keep on doing this until the value of n becomes 1 or 0, and that's how we are getting the 120 as an output saved into result, and then we are printing the result over here. Now let's talk about another classic example in recursive function is the Fibonacci series or sequence. So let's understand what is a Fibonacci series or sequence. Okay, so in mathematics the Fibonacci sequence is a sequence in which each number is the sum of two preceding ones, and the numbers that are part of Fibonacci sequence are known as the Fibonacci number. Okay, now if we have to define a Python function, or if we have to create a Python function that can calculate the nth Fibonacci number, then what we can do? We can simply start with defining the function. So let's define the function named as Fibonacci, and we are going to take an argument. For this argument, the first thing that we need to check is that if n is less than equal to 1, if that is the case, then return n. Okay, if that is not the case, then basically return Fibonacci function and n minus 1 Let me copy this, plus Fibonacci n minus 2. So earlier I told you, right, in mathematics the Fibonacci sequence is a sequence in which each number is the sum of two preceding ones, right? So if I take a number and check whether the sum of the two preceding number is Fibonacci number or not, right? So now if I basically call this function, this Fibonacci function, and save it into a result variable by giving 6 as the number input, and then let's print result. So if I run this, you will see that we have the output 8. How are we getting this output 8? The first time when 6 was given over here, the 6 goes over here as the argument, and it's getting checked that whether 6 is less than equal to 1. That is false, right? The moment it gets false, control comes to this else part, and it says return Fibonacci n minus 1. So it will go saying that 6 minus 1 basically, then plus it by 6 minus 2. Okay, let me put 6 minus 2. Now if I run this, and we are getting 9 over here, so that's my mistake, because instead of this 5 it should be, sorry, instead of 6 it should be 5, because now we have n over here, we have n minus 1, due to which this 6 become 5. Okay, and then 5 comes over here as the argument n, and this becomes n minus 2, which is 5 minus 2, which is 3. So we have 5 plus 3 equal to 8. Okay, so let's understand this program, what is happening over here line by line. So we defined a function Fibonacci that takes one argument, which is this n. Okay, then it checks if n is less than or equal to 1. If n is less than equal to 1, then basically it returns n, which is our base case. Else it will come to this part. In this else part, if n is greater than 1, then proceed to this else part and return this Fibonacci n minus 1 plus Fibonacci n minus 2, and it basically returns the sum of n minus 1 Fibonacci and n minus 2. So we are calling the Fibonacci function recursively with n minus 1 over here and n minus 2, and then we are saving the result value into this result variable by calling the Fibonacci function with the argument 6. Okay, so we are basically assigning the result into this result variable, and then we are printing the result, which gives us 8 over here. Okay, now let's talk about the last example that we are going to work in the recursive program, is the list of sum. Okay, so let's say that we would have a list of numbers. Let's say I have a numbers list which says 1 2 3 4 5. Okay, and I want the sum of these numbers. Then how we can write a program using recursive function? So the first thing that I can do is that I can define a function saying that list sum. In this list sum, I'm going to take an argument which is my list. So I have to give the argument which is an obviously a list. Okay, now I'm going to check the argument that has been given is list or not. Okay, so I'm simply going to say if not lst, then return 0. Okay, sorry, over here I have to give my list, then return 0, else basically return my list first value plus this function, take this function, okay, and take my list and the next value. Okay, now if I basically save the result into a number, sorry, into my result variable, saying that take this list sum, and as an argument if I give numbers, and then if I print result, and now if I run this, you can see that we are getting the output as 15. Okay, so what is happening over here is that we have defined a list of numbers from 1 to 5. Okay, then we have defined a function named as list sum that takes one argument, which is my list. Then we are checking if my list is empty or not. If it is empty, then return 0. That is my base case. If it is not empty, then proceed to the next line, which is else statement over here. And over here we are saying return my list 0, which is the first element of the list, plus that element 2 by calling the list sum function recursively with the list my list and excluding the first argument. Okay, so these examples demonstrate how recursive function can be used to solve a problem by breaking them down into a smaller subproblem, and the base case is crucial in recursive function to prevent the infinite loop or recursion. And with the help of this base case, we can ensure that the function terminates at the correct point. So we have already seen a couple of examples of recursive function, but is there any case that we can avoid this recursion? So whenever you're writing a program that can take a huge number of input data, then the recursive solution can be less efficient than the iterative solution due to overhead from multiple function calls. And for simpler problem, the recursion might make the code a little more complex and harder to understand. That's why whenever you have to make your code simple, and whenever you have huge amount of data on which the operation needs to be performed, then recursion is not the best option. Recursive functions are powerful for solving problems that have a natural recursive structure, but it's important to use them wisely to avoid performance and complexity issues. Happy learning and see you in the next video.